is Dr. Esther Trufan, and in this video, I'm going to demonstrate how to make a 0.1 molar acetic acid solution. For this experiment, I am going to use deionized water and glacial acetic acid. The concentration of glacial acetic acid is 17.4 molar, and so that is a very concentrated acid. But because we are diluting it by a substantial amount, the amount of heat that will be generated through the dilution process dissipates rather quickly, so we don't have to use an ice bath for this experiment. Still, because this is a dilution and we are making a solution of known concentration, the only equipment of choice, the only glassware of choice that we can use here is a volumetric flask. And because we want 100 milliliters of solution at the end, we need to start with a 100 milliliter volumetric flask. And we know that this is the right vessel because it says so on it. And it's a volumetric flask because it has the shape of one. For the experiment, we're going to need some glacial acetic acid and some deionized water. For glacial acetic acid, we're going to use a separate beaker so that we don't insert any pipettes or micropipettes inside the original container. And because of the high concentration of glacial acetic acid, we will be using a very small amount of it. So that means we need to use a micropipette instead of a graduated cylinder to measure out the original amount. For the micropipette, we need the micropipette and we need some clean tips. And finally, because the tips need to go somewhere, we need a waste container. And because we need the volume to be exactly at the mark in the 100 milliliter volumetric flask, we will need to use a pipette. Let's get started. For all acid dilutions, the first thing we do is add water to the volumetric flask. So in this case, we're going to remove the cap from the volumetric flask and then pour enough deionized water that it hits about halfway to 3/4 of a way in the volumetric flask. We can set the water to the side temporarily. Next, we need to measure out the amount of acetic acid. First, we're going to transfer some into our beaker. We just need a small amount. Then, based on our calculations, we need to set our micropipette to the right amount. And of glacial acetic acid, we're going to require 0.575 milliliters. So we just dial it to that number. When we get to the right number, we stop. Then we bring in our tip. We open it up. And without touching the tips at any point, we're going to slide the micropipette into it and create a tight connection. Then, to use the micropipette, there are 2 clicks in the plunger. To extract the solute, we're going to set the micropipette to the first click, and we will hit a little bit of resistance. At that point, we're going to slide the tip of the micropipette under the surface of the solution and very gently allow the solution to come up. Once we are done, we wait a second, and then we lift it up, move our micropipette tip inside the container, and then we push the plunger into its second stop. Once it got there, we wait approximately 2 seconds. And when we are done, we lift out our micropipette, let go of the plunger, and remove our used tip. For that, we're going to use the second button that's on our micropipette. Once our tip of the micropipette is above the waste container, we push the button and we slide it out. And now we can set both our waste container and the micropipette aside. The solute is in our volumetric flask. We have the right amount of solute. Next, we need to get to the desired volume, which is 100 milliliters. For that, all we need to do is add water in increments. Every time we add water, we swirl it to homogenize. Once the solution level reaches close to the neck of the volumetric flask, swirling is going to be very difficult. Once we added enough water that it's near the mark, we can switch to a pipette and slowly add enough water that the solution's meniscus will be right at the marking. Now we have the right amount of solute in here, and we have the correct volume, but it is not homogeneous yet. Next, we put the cap back on, and then we're going to move it back and forth approximately 3 to 5 times, and then set it aside. At this point, we have a homogeneous 0.1 molar acetic acid solution. As always, when making an acid solution, it is important that we standardize them before we use them for additional analytical purposes.